The king and queen of Dairyland throw a party each year for all of their citizens. One year, they could not decide what kind of party to host. The queen insisted on an ice cream social. The king wanted a pizza party. Unable to come to an agreement, they decided to seek out the people's opinions. They would divide their land into regions and count the number of pizza restaurants and ice cream parlors in each region. If a region contained more ice cream parlors, they would call the region an ice cream district full of ice cream lovers. If a region contained more pizza restaurants, the region would be deemed a pizza district, home to pizza eaters. The wily queen looked for an advantage. She saw that she could draw boundaries such that every district in Dairyland contained more ice cream parlors than pizza restaurants. She showed her results to the king and declared,
"There are obviously more ice cream districts, so we will serve ice cream at the party."
Her strategy of splitting majority areas is called cracking. The king said,
"That's not a reasonable map. At least some of our citizens prefer pizza."
He saw that there were more ice cream parlors in total, but he cleverly drew lines so that there were more pizza districts than ice cream districts. He declared,
"The people have spoken. We shall dine on pizza at our party."
His strategy of sacrificing some districts in order to achieve a majority in the rest is called packing. Of course, in our land, we don't have kings and queens making borders based on junk food preferences. We have politicians creating voting districts based on political preferences. And we don't vote to decide a statewide celebration. Instead, our districts determine the balance of power in the government. There are many ways to draw voting districts to deliberately advantage one group over another. This is called gerrymandering. Unscrupulous politicians can decide district borders in order to give more power to people of a certain age, religion, education level, or race. To have a representative government, we need to minimize gerrymandering and ensure that voting districts are drawn in an unbiased way. Gerrymandering is difficult to identify and measure, but mathematicians have strategies to address it. We say a map is fair if it represents the population. Unfortunately, it's not always easy to tell. One way to determine if a map is fair is to look at how compact the regions are. If a region is not compact, then this could be a sign that the district was not drawn fairly. For example, consider the two regions below. We can look at these regions and see that the first region doesn't look as compact as the second region, which could be an indicator that it was not drawn fairly. Geometry can be used to describe how compact a region is. For example, we can compare the perimeter and area of a region. In this situation, the areas are the same, but the region on the left has a larger perimeter, which tells us that the region on the right is more compact, as we expected. This is one way to think about compactness, but mathematicians are unsure if this is the best way to think about compactness. Here is another possible way that we could think about compactness. Imagine you stretch a rubber band around the region and look at the area inside the rubber band compared with the area inside the region. These regions still have the same area, but the region on the left has a much larger area inside the rubber band than the region on the right, which tells us that the region on the right is more compact. These are just two examples of ways that mathematicians think about compactness. Because maps in real life can be extremely complex, it's likely that we really need to use multiple perspectives in tandem in order to accurately capture the situation. A different approach to determining the fairness of maps stems from a basic question. If we consider all of the ways we could draw boundaries on a map, what are the odds of choosing a map with the same outcome as the existing map? For example, consider this simplified situation. The polygon represents a state, and the red and blue dots reflect some preference of the people. As a first step, we'll consider all of the different possible ways to partition it up, given constraints coming from state laws, geography, and so on. Here, we'll suppose that there are only the 6 possibilities drawn, but in real-world situations, there are often billions or more. Now we can measure something about each of those possibilities, such as how many districts are predominantly red, and then we can calculate the odds of each possibility actually happening. We can then group them up. How many result in just one red seat? How many in 2 or 3? Since we have all of the possibilities, the actual outcome is one of them, so how likely was it? If the likelihood was very low, this can be an indication that gerrymandering has occurred. In general, we can think of the collection of all possibilities as points that live in a space, which can be near each other or far away. This could be like the ordinary 3D space we live in, or generalizations to higher dimensions, where the coordinates can be parameters such as population density and racial makeup. In general, this space can be quite complicated. However, similar mathematical tools apply, and we can still measure how likely the certain combinations are. There are entire branches of mathematics that have developed tools to analyze and quantify situations like these, which means that there are many tools available, and computing these probabilities is exactly the type of numerical problem that computers are good at solving. There is some nuance here. Just because a map is unlikely or non-compact doesn't always mean that gerrymandering has occurred. In the real world, there are many other factors which influence districting. Not just population density and racial makeup, but educational background, gender, income, cost of living, and other demographics, as well as geographic features such as mountain ranges or bodies of water. And so there is often no clear-cut answer, and the best approach often uses an ensemble of measurements and methods in tandem to offset the shortcomings of any single one. Ultimately, however, it rests on actual human beings to analyze and assess all of this information in order to reach a final and fair decision. To learn more about the mathematics of gerrymandering, check out the sources and information in the links below the video. Thanks for watching!